Hello and welcome back. In this video we discuss about Newton's third law of motion. Earlier we have seen that if the net force acting on a body is zero, the body will either stay at the state of rest or will move with a constant velocity. Later on in second law we have seen that if there is a net force acting on a body, it will accelerate in the direction of force, and the relationship between force and acceleration is given by the equation F equals ma, where m is the mass of the body. Newton's third law states that to every action there is always opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary paths. Mathematically, we can say that if an object A exerts a force FAB on an object B, then the object B will exert an equal and opposite force FBA on object A, such that FAB equals minus FBA. In this video, we discuss few examples of this principle. Consider a block of mass m resting on a table. Action is the push of the block on the table. This push is caused by the gravitational pull of the earth on block, which is the weight of the block. This push due to weight creates a very small deformation on the block, and due to this a reaction is acting on the block from the table. This reactive elastic force is called the normal reaction N from the surface, which is perpendicular to the contact area. If the table is made of soft material, the deformation will be more. If the reactive force is insufficient to balance the action, the table may collapse due to this action. Now let us do some thought experiments. Imagine that you are pushing a rigid wall fixed on ground with a force of 1 Newton. According to Newton's third law, this action will produce a reactive force equal in magnitude but opposite in direction. The elasticity of wall is providing this reactive force. If you increase the push to 5 Newton, then the wall reactive force on you will be increased to 5 Newton. The wall is pushing man, but he is stationary because of reactive frictional force acting on man's foot from ground is balanced with the force from the wall. Now imagine that the man is on a roller skate where frictional force is less. If a man pushes the wall, the reactive force acting on the man from the wall moves him backward. That means, in this case, the reactive force moves a person backward with an acceleration. Consider another case where two identical roller skaters are pushing each other. Due to the reactive force developed, both will move apart equally in this case, due to the action and reaction. Another example is the principle of rocket propulsion. Fuel and oxidizer burns and create high pressure gas that flows out with the high velocity from the engine, creating a change in momentum and resulting force. The reactive force developed on the rocket body propels it in the opposite direction. Finally, we have few examples where objects are subjected to a force that produces acceleration. A frame of reference attached to such objects are non-inertial frames of reference. We have seen in earlier videos that objects in non-inertial frames of reference experience inertial forces. With this background, think about these three scenarios as shown. We will explain this in part 2 of this video. Till then, enjoy these three questions. Thank you very much.